Hey everybody. So you can see here I've got up one of the osmosis data sets that we were working with. I picked the 6th hour one for no reason. Um, and I'm going to clear out some of this t-test stuff here. Oops, I forgot one. And let's take a look first at this graph. And I just got an email. So let's see here. I'm going to make this a scatter plot. And we can do some cool stuff with this. Under Customize, we can add a trend line in there, and that's really awesome. We could even tell it to give us our correlation value if that's something that you know from Psych or something like that. 0.81, it's pretty strong correlation. We could actually have it do an equation as well if we wanted to calculate where the exact intercept was here on the x-axis. Now, let's close this guy here. Let's move it over here. Now, the problem is that we can add error bars to this graph by clicking Series Error Bars. And you can see some error bars pop up there, but all we've done is assigned it an error of 10%. What does that mean? Where did we pick that number from? Oh, well, I can be sweet and change it to 15%. We changed it to 15%, but what does that represent? If you watched the videos that I posted up on the Haiku page, you'll see that error bars are really great at showing something like standard deviation to show you how things get overlaid. And as a result of the overlaying of data, you can kind of see that there is or is not a significant difference between things. So I'm just going to get this out of the way here. And I'm going to show you how, thank you to Leah Nyholm, how to actually put error bars in there that represent the standard deviation. Now, unfortunately, when we do this, we can't have a trend line on this graph. And so you're going to have two different graphs. So we're still going to graph our average percent change here. We're still going to use 0, 1, 2, 3, 4. We're going to make a little area here that looks a little weird. So we're going to have our 0, 1, 2, 3, 4% areas here. Then we're going to do the same thing going across. So we've just kind of created X and Y area that has the exact same thing in there. Now, for our 0% situation, we had an average percent change of 16.95%. So I'm going to put this right here at this intersection of 0 and 0. For our 1% cup, we're going to put that here at negative 10.32, but you can see that I have it at the intersection of the two ones. We can do the same thing here. Keep going on down the line. Now, when we graph this, we do the same thing as before. Insert, chart. Whoa, that's a lot of numbers. That's not what we want. We want a scatter plot. So we go down here, check this out. Can you see now that each of those points is a different color? Over here, they're all blue, but over here, they're each a different color. Google is treating these things differently now for some weird reason, and I'm not exactly sure why. That doesn't matter because this weird reason is going to allow us to do what we want to this graph. So I'm going to go to Customize. I don't like that legend over there doesn't have anything on it. So I am going to select for the position. I'm going to select none. I'm going to get rid of that. Under series, I'm going to pick error bars. Now, here's the cool thing. So we want our error bars to represent standard deviation. What we can do now is under series, we can select each individual point. And I can go up here and say, okay, my standard deviation was 1.72 for this first series, for this first number. So I can change it to a constant at 1.72. Now that error bar is showing us 1.72 above 16.95. That's where these numbers are that I'm saying. And 1.72 below 16.95. Let's go back over here to customize series. Let's pick our second one now. We want a constant 1.16 with our standard deviation for our second one. Our third one got a little bit bigger, 2.86. Our fourth standard deviation was the largest with 6.12. We should see that be pretty big on here. Finally, our fifth one had a standard deviation of 1.64. Well, now when we take a look at this graph and we take a look at this data, we can see, number one, most of this data right here totally fits in to this little space right here. That shows us that there's not a significant difference between these two situations. Our t-test bears that out, I bet. But do you see how the 2% cup doesn't really overlap at all with the 4% cup? I bet our t-test would tell us that as well. So we have error bars now completely customized. We can give our chart a title. Average percent change versus salt solution. We can give our horizontal axis a title, percent salt solution. Pops up down there. We can give our vertical axis a title, average percent change. All right. Now we have a second graph that we can put into our conclusion when we maybe need to talk about the reliability of data. Look how spread out this is. It means our data is pretty far from the average, and so our 3% cups maybe aren't that reliable, but I do appear to have an outlier here that maybe I can talk about. Okay, that is it. Now let's see if I can figure out how to turn this off.